The recent leave strategy concerning room experts has concluded that, using our latest 11 billion initiative, it would take an extraordinarily long time before this endeavour becomes a reality. If everything proceeds as planned, the voyage to Proxima B is expected to take about 20 years. Consequently, it will be quite a while before we can speculate about the existence of life on that planet. The Deep Space Telescope has been central to exploring whether we are truly alone in the universe, continually offering evidence through its discoveries. The James Webb Telescope has identified some fascinating human-like objects far beyond Earth, bringing us closer to answering this profound question. Our search for life beyond Earth has been an ongoing drive across all human activities, so much so that we have created numerous theories and media around it. Our fascination with our role and significance in the cosmos remains a constant. It's deeply embedded in our nature to continuously seek a companion. No matter how similar we might be, this drive propels us toward finding answers. Yet even if we get closer, can we be sure these answers are what we're truly looking for? Or are they merely distractions? Join us as we delve into the slow and steady discoveries made in the realm of galaxies and planets, on the journey to uncover something we might not be ready to witness: the distant lights of other worlds. Scientists may have unearthed the most important discovery in history. Back in 2021, when the James Webb Space Telescope was being designed, a rather bold and speculative inquiry emerged about the capabilities of our technology. The big question was whether, in the future, our telescopes could detect artificial light on distant planets, such as Proxima B, the closest exoplanet to Earth. Proxima B, situated about 4.25 light-years away, was thought to be tidally locked, having one side constantly facing its star, while the other side remains in perpetual darkness, much like our moon. A speculative technological advance could potentially transport energy from the day side of Proxima B to its night side, using solar panels that generate power from starlight. A study featuring scientist Manis Ving among the contributors showed that a remarkable combination of solar cells on the day side could be linked with future telescopes. This is particularly relevant now, as the James Webb Space Telescope has been developed, and it would allow us to expand our search for artificial light on exoplanets like Proxima B. In fact, the fact that the James Webb Space Telescope was able to carry out this exact task in 2024, utilizing its higher resolution and more advanced capabilities, is significant. The telescope might have already detected the lights we were searching for, potentially ushering humanity into a new era of scientific exploration. We should dive deeper into the world of exoplanets and galaxies to understand how this remarkable feat was made possible. The mission of the James Webb Space Telescope, JWST, to explore Proxima B is rooted in humanity's age-old curiosity about the universe. Ever since the beginning of recorded history, humans have pondered the possibilities of our place in the cosmos, who we are, where we come from, and where we are heading. These timeless yet profoundly challenging questions have been the focus of human inquiry for centuries. With the advancement of modern technology, one wonders if we are any closer to answering these pressing questions. If you were to ask a philosopher, he might suggest that we are only at the very beginning of truly understanding our existence in the universe. On the other hand, if you were to ask an astronomer, they would eagerly share the latest discoveries made about the universe using cutting-edge tools. These instruments, though often overlooked by the general public, are a direct reflection of human development. We now have the world laid out before us, and it's time for us to expand our horizons and grasp the universe with the same confidence. One such way to achieve this is through the efforts of astronomers and space experts who have been instrumental in developing new technology for the discovery of what may very well be light on distant planets. The James Webb Space Telescope, a product of human innovation, is central to this mission. This infrared space telescope has begun addressing these age-old questions, pushing the boundaries of what is possible in space exploration. You might be wondering, what exactly is Proxima B, sometimes referred to as Alpha Centauri Proxima B? It is a super-Earth exoplanet that orbits an M-type star. To clarify, super-Earths are planets that are more massive than Earth, but less massive than ice giants like Neptune or Uranus. They are unique in that they can be composed of gas, rock, or even a combination of both. Their sizes can vary, with some being twice the size of Earth, while others may be several times more massive. Proxima B fits the definition of a super-Earth and is classified as an exoplanet, meaning it orbits a star outside our solar system. The first potential evidence of an exoplanet was discovered as early as 1917, though it didn't generate much interest. It wasn't until 1992 that confirmation came with the first verified exoplanet discovery, which stunned experts. Another exoplanet, first detected in 1988, was confirmed in 2003. As of April 2024, there are 5,153 confirmed exoplanets in 4,161 planetary systems, with 896 systems containing multiple planets. Many of these discoveries are orbiting M-type stars. To understand what this means, it's crucial to know that an M-type star is the smallest type of star in the main sequence, hence the name red dwarf. Red dwarfs are the most common stars in the Milky Way, though they have low luminosity, making them difficult to detect, which complicates our search for planets. These stars have varying classifications and names based on their size and temperature, such as M dwarfs. Proxima B has a mass that closely resembles 1.07 times that of Earth. Strangely, it only takes 11.2 days to complete one orbit around its star, compared to Earth's 365.25 days. You can estimate the size of the star Proxima B orbits by considering the full electromagnetic spectrum. The star's total luminosity is a mere 1.6% of the sun's brightness. In the visible light spectrum, it only shines at 5 to 6% of the sun's intensity, producing far less light energy compared to the sun. Over 85% of its emitted energy is infrared radiation. Proxima B's discovery was announced in 2016, but what makes it stand out from the thousands of other stars, planets, and worlds in our galaxy? There are several reasons why. Astronomers are particularly focused on Proxima B. Most notably, Proxima B is the closest known exoplanet to our Sun. While 4.2 light-years may seem distant to us in the vastness of the universe, it is relatively close. Proxima B is part of the Alpha Centauri star system, a triple star system, and despite its low brightness, it is still one of the brightest objects in the night sky, trailing only Sirius and Canopus. What makes Proxima B even more intriguing is its potential habitability, as it resides within the star's habitable zone, the region where conditions may be right for liquid water to exist. This possibility has spurred intense interest among space scientists, leading to further investigation of the system's potential to support life. This is where the James Webb Space Telescope comes into play. The four primary goals of the JWST to search for light from the first stars and galaxies that formed after the Big Bang, study the evolution of the universe, investigate the formation of stars and planets, and examine planetary systems and the origins of life. As the JWST continues its investigation of exoplanets like Proxima B, we draw closer to understanding these goals. Searching for extraterrestrial life is now a priority for the mission, which is particularly relevant. Given humanity's innate curiosity, exploring the unknown is a natural extension of who we are, as a species, always questioning, investigating and exploring everything that moves or remains still. It makes perfect sense that a mission like this would be undertaken on such a grand scale. Imagine the monumental task before us. With a vast universe filled with endless possibilities, we are fortunate to be the ones searching for signals from distant civilizations, the search for extraterrestrial intelligence. CI can be likened to a high-stakes game of cosmic hide and seek, with humanity as the seeker and the universe as the hiding spot. Researchers in this field are akin to skilled detectives scanning radio signals for any faint whispers of intelligent life. Beyond Earth, this endeavor began in the 1960s, when renowned astrophysicist Frank Drake first detected radio waves from these stars. While no extraterrestrial visitors have arrived yet, the search continues. The quest for extraterrestrial signals requires patience, often spanning decades or even centuries. Very few definitive extraterrestrial signals have been found, but the quest continues to inspire hope, particularly as the James Webb Space Telescope gathers data from exoplanets like Proxima B. This expanding field of exploration could one day lead us to confirm the existence of extraterrestrial life, or perhaps we will only receive ambiguous signals that leave us with more questions than answers. Regardless, the detection of lights or signals from distant worlds like Proxima B could represent the next giant leap in humanity's eternal curiosity, where the pursuit of knowledge and technological advancement intersect in a thrilling cosmic adventure. As we continue our search, we remain hopeful that one day we will find definitive evidence that we are not truly alone in the universe. The discovery of artificial lights or other signals from far-off exoplanets like Proxima B would be a monumental step toward answering one of humanity's most fundamental questions. Are we alone in the cosmos? As the James Webb Space Telescope continues its work, its findings will undoubtedly spark further discussions, research, and perhaps even challenges to our understanding of life intelligence and the very nature of the universe. The potential implications of these discoveries go far beyond curiosity alone. The possibility of confirming life on Proxima B or another exoplanet would force us to rethink our place in the universe. Could life on other worlds evolve in ways similar to our own, or would it represent something entirely different? Would these life forms follow familiar patterns of growth and development, or would they challenge everything we know about biology and consciousness on Earth? Even if we don't find direct proof of intelligent life, the mere detection of artificial lights or signals from distant planets would still carry profound implications. It would mean that intelligent civilizations exist elsewhere in the universe, potentially capable of altering their environments in ways that we can recognize. This would suggest that intelligent life is not a rare phenomenon, but rather an inevitable outcome of specific conditions in the cosmos. However, as exciting as this potential discovery is, we must approach it with caution. The confirmation of extraterrestrial life raises numerous questions, including how we should respond. How will humanity react to the discovery of intelligent life? Will we approach it with respect, curiosity, and scientific rigor? Or will the revelations provoke fear, panic, or even political conflict? History has shown that new discoveries, especially those that challenge long-held beliefs, can elicit unpredictable responses. As we venture further into space, it is essential to consider the ethical and moral implications of our search. If we do discover life, particularly intelligent life on another planet, what responsibilities do we have as stewards of Earth? What ethical guidelines should govern our interactions with other forms of life, whether microbial or advanced? These questions may not have simple answers, but they will undoubtedly be central to the ongoing discussion. As humanity continues its journey into the stars, the search for life beyond Earth, driven by instruments like the James Webb Space Telescope, is a thrilling intersection of science, philosophy, and humanity's future.